Okay, hello. In this video, we're going to be talking about matrix transposition. So, I'm going to try to explain this as simply as possible, starting with number one thing. What even is a matrix transpose? So, a matrix transpose is simply flipping a matrix over its main diagonal. So, another way to think of it is rows become columns and columns become rows. And that's really all a transpose is. So, I'm going to start you off with an example. Suppose we have this matrix A. Let's let it equal 1, 2, 3, 4, 5, 6. So this matrix has two rows, 1, 2, and 3 columns, right? 1, 2, 3. So the first row is 1, 2, 3, and that will become the first column. And the second row is 4, 5, 6, and that will actually become the second column. So a transpose becomes like this: 1, 2, 3, 4, 5, 6. So notice that in the original, the matrix was a 2 by 3, and in the transpose, it becomes a 3 by 2. So this is 2 by 3, and this is 3 by 2. So now we move on to the second thing. I want to talk about is the symbol for transpose. So if the matrix is just A, its transpose is written as A, T, as you've seen before. So you read it as A transpose. Number 3 I want to talk about is the rule. So simply remember that rows become columns or that columns become rows. So nothing changes except where the numbers are located. The fourth thing I want to talk about is the main diagonal. So as I've said before, the transpose flips across the main diagonal. So the main diagonal goes from top left to bottom right. So I want to look at an example. Say as an example, we have this matrix, 1, 2, 3, 4. The diagonal numbers are 1 and 4, and those numbers stay where they are. Everything else swaps. So 2 swaps with 3, for example. So the result will be 1, 3, 2, 4. The fifth thing I want to talk about is what actually swaps. So every entry swaps. So the row and column becomes column and row. If something is in row 2, column 3, after transposing, it becomes row 3, column 2. So it's just like reversed. And now I want to look at an example. So say we have this matrix, right? We have 5, 8, 7, 1. The number 8, it's in row 1 and column 2. So after transposing, it moves to row 2, column 1. So the result looks like 5, 7, 8, 1, where the number 8 moved to row 2 and column 1. The sixth thing I want to talk about is size changes. So if A is m by n, right, then A transpose is n by m. So as an example, a 3 by 5 matrix becomes 5 by 3 after transposing. The seventh thing I want to talk about is what doesn't change. So the numbers themselves don't change, only their positions change. The eighth thing I want to talk about is double transpose. So if you were to transpose twice, you would get the original matrix back. So A transpose transpose just equals the original A matrix. So think of it like flipping something twice. It ends up where it started if you flip it twice. The ninth thing I want to talk about is the transpose of a row vector. So suppose we have this matrix, right? 2, 4, 6. This is just one row. And after transposing, it becomes 2, 4, 6. So it becomes one column. The 10th thing I want to talk about is the transpose of a column vector. So if we had this being our original 9, 3, 1, the transpose will be 9, 3, 1 like this. So it's a transpose of a column vector. The 11th thing I want to talk about is square matrices. So a square matrix will always stay the same size, will always stay the same size. So as an example, a 2 by 2 becomes a 2 by 2, and a 3 by 3 becomes a 3 by 3. So the size doesn't change because the rows equal the columns, which is what we call a square matrix in linear algebra. The 12th thing I want to talk about is symmetric matrices. So sometimes after transposing, sometimes nothing changes. So for example, 1, 4, 4, 3, the transpose matrix will become 1, 4, 4, 3, which is exactly the same as our original. So this is called a symmetric matrix, sorry. So by definition of a symmetric matrix, A original equals A transpose. Now I want to talk about the important properties of matrix transposition. So property number 1 that we've already went through is the transposing twice, is t equals A. Property number 2 is a transpose of a sum. So say we have this, A plus B transpose equals A transpose plus B transpose. So we transpose each matrix separately. Property number 3 is a transpose of a difference. If we have A minus B transpose, this equals A transpose minus B transpose. Property number 4 is transpose of a constant multiple. So we have constant A transpose equals constant A transpose. So this means that the constant stays the same. Now, property number 5 is very important, and the most important one is the transpose of a product. So if you have A times B transpose, this equals B transpose A transpose. So notice that the order reverses, A, B, B, A. This is probably the most tested transpose property. Now that we have all our properties down, I want to go over some common exam problems. So let's just say we have to find A transpose if A matrix equals 2, 5, 8, 1, 4, 9. So step 1 is that the first row becomes the first column. And step 2 is that the second row here will become the second column. So our final answer will be 2, 5, 8, 1, 4, 9. And that's number 1 done. Exam problem number 2. Let's just say we had to transpose 3, 7, 2, 8. So the diagonal stays, and we have to swap 7 and 2 as we learned. So the result will actually be 3, 2. Whoops, sorry. The result will actually be 3, 2, 7, 8. Now, example number 3, we have to find the transpose of 4, 6, 9. Yeah. So this is actually a column vector, so we must turn it into a row as we saw. So the answer will just be 4, 6, 9. Now, example number 4, we're going to look at some properties now. Given this matrix A, we have 1, 2, 3, 4. We want to find A transpose transpose, right? So when we transpose again, so first let's go through it, right? Let's go through the actual proof. Our first transpose will be A transpose equals 1, 3, 2, 4, as you've seen. And then we have to transpose again. It's double transpose, right? So then the rows become columns again. So our answer is just back to 1, 2, 3, 4, which is exactly the same as the original matrix. Now we're going to look at example number 5 using some more properties that we've learned. So given this matrix A, let's set it equal to 1, 2, 3, 4 again for simplicity. And given matrix B equals to 5, 6, 7, 8, find A plus B transpose. So step 1 is to add the matrices. So we've learned how to add matrices before, right? By adding the corresponding numbers, yeah? So let's clip and crop this and then let's continue after that. So step 1, when we add the matrices, A plus B will become 6, 8, 10, 12, right? And then step 2 is with the transpose. It's where we swap the 8 and the 10, the off diagonals, right? So then the answer will be 6, 10, 8, 12 is our final answer. Now we'll move on to example number 6, probably our last one, and this is quite a common exam question that I have seen in my area. So if matrix A equals 1, 2, 3, 4, yeah, and matrix B equals to 5, 6, 7, 8, the question is, what is AB transpose, yeah? And what is AB transpose without multiplying? So we must actually use the property that we learned before, right? Our property AB transpose equals B transpose A transpose. We notice that the order changes, right? So the final answer will just be this. Will just be that because I asked like what is this AB transpose without multiplying, which is just this. It's the property itself. So now I want to go on to 3 common mistakes I've noticed a little bit. So mistake number 1 is forgetting to switch rows and columns. So always remember that rows becomes columns. Mistake number 2 is I see some people change the numbers. You never change any of the actual values themselves and only move them. And mistake number 3 is forgetting the product order reverses. So for example, this is actually wrong. AB transpose equals A transpose B transpose. This is actually very, very wrong. So the correct, as we've seen like a few times before, is AB transpose equals B transpose A transpose. Now, I believe after this, we only have really one more topic to cover. Let me just double check. Yeah. So it does seem like we really have one more topic to cover after this, which is Comera's rule. So, yeah. This seems like it's going to be the second to last topic, which is amazing. And yeah. Well, now I will I don't know. I will tell my mother I love her. And once again, China number 1, okay?